In this video, we are going to talk about how to find the area of regular polygons. Remember that regular means that the shape is equilateral and equiangular. So all the sides and all the angles are the same. So let's take a look at a couple vocab terms that you're going to see. So feel free to pause the video, write this down, and then I'm going to explain some of it. Okay, so a couple terms that we need to talk about is the center of a polygon. So if you look at this picture, we've got a hexagon in here. It is inscribed within a circle. Okay, and remember, inscribed means that all of these vertices of the hexagon touch the circle and it's inside. So the center of the polygon is the center of that circle as well, the center of the circumscribed circle, or the circle drawn around there. And so then what happens is you've got that center, and then you've also got a radius of the polygon, because the polygon vertex is on the circle. So the radius of the circle is also the radius of the polygon. So the polygon's radius goes from the center of the polygon to a vertex. Okay, so that's a radius. You got a bunch of them. You got 6. One here, one here, one here, one here, and one here, right? So I got multiple radii in a polygon depending on the number of angles. And then we have what's called the apothem. And that's part of your area formula, is you need to know the apothem. And the apothem is the perpendicular segment from the center to the edge. Okay, so center to the edge, and you'll see this 90-degree angle. It also splits this central angle right here in half. It splits this triangle in half as well. So these kind of two little triangles here are identical. But you have an apothem to every side as well. Okay, coming out of the center. So you'd have one here. Okay, you'd have one here. Another one here, here, here. Okay. And so that's the apothem. And then the central angle is just the angle between two consecutive radii, and we're going to look more at that on the next screen. So if we were going to do finding the central angle here, so central angle again is just the angle between two consecutive radii. Okay, so here would be consecutive radii here. And I could draw all of these in, right? So we'd have 5 in this case because we've got a pentagon, okay, a 5-sided figure. So there's going to be 5 of these central angles, and all of them are going to be identical. And we know the total is 360. So to find one central angle measure, we'd do 360 divided by 5. And that would give us the central angle measure in this pentagon, which is 72 degrees. For this next shape, so it's, let's count the sides. So we've got 1, 2, 3, 4, 5, 6, 7. So this is a septagon. So again, you could draw in all of these radii here, and you'd end up with 7 central angles, same as the number of sides. So to figure out a central angle here, we would do 360 divided by 7. And that would get us our central angle measure of 51.4 degrees. For a triangle, we would end up with 3, okay? Just like the number of sides, triangle 3. So 360 divided by 3, and you'd get 120 for each of those angles. And finally, a hexagon. So a hexagon is 6-sided, so you're going to get 6 of these central angles, and so 360 divided by 6 is 60. And kind of a cool thing with the hexagons is a regular hexagon, when you split it up with all its central angles, every single one of these is an identical triangle, because you get 60-degree angles here. Isosceles forces these to be 60, so you end up with 3 with equilateral, equiangular triangles all the way around. So if you know the length of this green segment, it's the same as the sides. So let's take a look at, finding the area. And I didn't really say about the area formula, so let's go back. So the area formula is the apothem times the perimeter divided by 2. Okay, so for area of a regular polygon, it's going to be, let me just write it out. So it's going to be the apothem times the perimeter of the shape of the hexagon or whatever the polygon is, and then divided by 2. Okay? Sometimes you'll see it written as 1/2 apothem times perimeter, right? So multiplying by 1/2 or dividing by 2, same thing. So let's take a look at these. I'm just going to write the formula up here. So apothem times perimeter divided by 2. So in this one, they give us the apothem. So here's your A, your little a. And then they give us a side length. Okay, and remember that this is a regular polygon, so all the side lengths are the same. So we can say 1, 2, 3, 4, 5, 6, 7. So the perimeter is going to be 7 times 12. And so the perimeter here is going to be 84 yards. So to get the area of this septagon, we would do the apothem, which is 12.47, times the perimeter, which is 84, and then divide that by 2. And you can just type that in your calculator. So 12.47 times 84 divided by 2 gives us 523.74 yards squared. Then this next one, okay, again, we need the apothem and the perimeter. So this one, okay, remember the apothem on a picture. So this one they just straight up told us. This one we need to look at the picture. So remember the apothem is the segment that is perpendicular to the side. So this segment right here is our apothem, and we don't know it. So we're going to have to find it. And so if we're taking a look in this little triangle, let me just redraw this triangle down here so we can just take a closer look at it. So we're looking for this. We know this one is 4 and we know this one is 8. It's a right triangle, so we should be able to do Pythagorean theorem. C squared equals A squared plus B squared. Remember that your C is the side across from the 90, so our 8 is our C value. So we have 8 squared equals X squared plus 4 squared. So 64 equals X squared plus 16. So then we'll subtract 16 from both sides and get 48 equals X squared. Then you can square root that, and we'll get 6.93. So X, or the apothem, equals 6.93 centimeters. So this right here is 6.93. So we've got our little a, our apothem. Now we just need the perimeter, okay? And so your perimeter is the distance all the way around. So we need the length of this whole side here. So this piece is 4. This one, remember what I said? If you connected here, these two triangles are identical. So this little piece right here is also 4 centimeters, meaning that the total of each side is 8 centimeters. So for the perimeter, we have a hexagon, which has 6 sides. So 6 times 8. So the perimeter is 48 centimeters. Then we can go ahead and plug it into the area formula. So area equals the apothem, 6.93, times the perimeter, which is 48, divided by 2. So 6.93 times 48 divided by 2, and you get that the area of this hexagon is 166.32 centimeters squared.